Hey guys, this is me Karthikeyan and this is our channel Teachers of Backbenchers, and with your constant support we have reached more than 2000 subscribers. Thank you for that, and keep supporting us and like, share, comment and subscribe our channel for supporting us. And after a long time we are starting this video, and this is the 20th video of our data structure playlist. So far we have completed what is a data structure, what are the various types of data structures. So in that linear data structure and non-linear data structure, we have seen what is a linear. In linear we have seen what is a list, what is a stack, and now we are going to start with Queue ADT. And let me get into the concept. And Queue ADT is nothing but a data structure which follows the concept of first in first out. Whereas in the previous video we have seen what is a stack, and stack follows first in last out concept, and whereas in Queue ADT it follows the first in first out concept. And so getting back to the concept, and let's assume this is a queue data structure, and queue data structure we have allocated a memory of 4 for an example. Okay, and there are some properties for queue data structures which is unlikely opposite to the stack data structure. So we are having two openings, one at the rear and one at the front. One is for the insertion process and one is for the deletion process. Okay, so inserting and deleting an element from a queue data structure is very simple. So we are inserting all the elements at the rear part and we are deleting all the elements at the front part. Okay, so insertion at the back and deletion at the front. So this is queue data structure. So the process of inserting an element into the queue data structure at the rear is called as enqueue. Okay, this concept is called as enqueue concept. And the process of deleting an element in front of the data structure, queue data structure, is called as dequeue. Okay, enqueue and dequeue. Enqueue is for inserting an element into the data structure in the rear position, and dequeue is for deleting an element from the queue data structure in the front position or from the front position. Okay, now with that I have written a concept called as overflow and underflow. This concept is similar to the stack data structure, but here overflow is nothing but when the queue data structure is full, the memory is full, we can't insert any other element. So that concept or that situation is called as overflow. When a queue is full, we can't insert any further element, which is said to be known as overflow. And when the queue is empty, we can't delete any other elements because there is no other elements. So that concept is called as underflow, where we can't delete any other elements when there is no element at all. Okay, so this is concept is called as overflow and underflow concept. Okay, so now let me show you a model based queue process. It is a very simple process. Okay, so let's assume this is a queue data structure, or assuming it as a queue data structure. In real time applications we are having n number of applications. Wherever there is a queue, we are implementing queue data structure. The sudden idea or sudden example which comes to my mind is getting a ticket from a theater. So the first person who's standing in the queue will be getting the first ticket, and the last person who's in the queue will be getting the last ticket. So this is called as first in first out concept, or last in last out concept, whatever it may be. So let's assume this is a queue data structure. Okay, so this is a queue data structure. I have divided it into 4 memory slots similar to this one. Okay, so now we are going to insert an element and delete an element from this queue data structure. Okay, so how are we going to do this is, so let's assume this is memory 1, 2, 3 and 4. Okay, we know that insertion is at the back and deletion is at the front, right? So the first color is orange, so let me take an orange. So we are going to insert an element from the rear. Okay, and the element will be placed in the first position. So here is the first element, it has been inserted from the back, and this is the first element. Okay, and the second element is purple color. So we are going to insert the second color, purple color, into this one. Yeah, it is there. And then the third one is pink, and the last one is blue. So now the queue is full according to our concept, correct? So how would we know that the queue is full? Now let's assume we are inserting an overflow concept. So I'm going to insert the element. So let us see the concept is full or not. So yes, so if I'm inserting an element in the front, it is pushing the other element. So we know that the queue is full. Okay, so this concept is called as queue overflow. The queue is full and we are trying to insert an element and it pushes the other element out. It is not possible in the data structure. So this is called as queue overflow. Okay, got it? So this is called as queue overflow concept, and now we will delete each and every element. Okay, so we will be deleting the first element. So the first element orange is being pulled out. So if it is being pulled out, then the position will be appropriately next coming. So now the first element will be purple, second element will be pink, and third element will be blue, and the last element will be empty. So I am dequeuing another element. So dequeuing means the element in the first cell will be deleted, whatever the element may be. Okay, and the next element will be pink color. So the pink is being dequeued or deleted the element, and the last element will be blue color. So I have deleted or dequeued 4 times. So which means that the queue is empty. Yeah, you can see that the queue is empty now. So it is an empty queue, and if you want to delete it, then that process is called as dequeue process. Okay, so this is how we are inserting and deleting an element from a queue. Okay, so now these are the concepts, and this Queue ADT can be implemented in 2 segments, like we have seen in the video for starting tutorials. It can be implemented in either array implementation or linked list implementation. So the first type of implementation is array implementation, and second type is called as linked list implementation. Okay, so array implementation and linked list implementation are the 2 types of concept in which we can insert the we can apply the queue data structure. So the implementation process of queue data structure will be seen in the upcoming videos, and hope you guys understood what is a queue data structure and how we are inserting and deleting a process and what are the important terms of it. So the upcoming videos will be consisting of what is how to implement a queue data structure in array concept as well as in linked list concept with examples, and we'll be seeing some concept called as priority queue, another DQ, double-ended queue is there, circular queue is there. So we'll be seeing those concepts also, and hope you guys like this video. So like, share, comment, and whatever doubts you have, you can comment it in the comment section, and don't forget to subscribe the channel. And until we meet in the next video, it's Karthikeyan signing off.